Welcome back. This is Nick Agram. I will be discussing systems of linear equations. System, that means we're discussing about more than one. So if I have equations here, linear equations in two variables, I will limit this discussion into two variables, not three. Maybe later you can do that, but right now I am going to limit this discussion in two variables. You have y is equal to y sub 1, let's say, is equal to m sub 1, x sub 1 plus b sub 1. And then we have y sub 2 is equal to m sub 1, x sub 2, plus b sub 2. That means, as I discussed before, if m sub 1 is equal to m sub 2, then no solution. If you have m sub 1 is not equal to m sub 2, then you have one solution. That means b sub 1 is not equal to b sub 2 either. Then you have one solution. But if you have m sub 1 is not equal to m sub 2, no, sorry for that. Is equal to m sub 2 and also b sub 1 is equal to b sub 2, then you have many solutions. Okay. There are different ways in solving systems of linear equations. We have the graphical solution. The other is algebraic solution. Not solution, methods. Method, not solution. Algebraic methods. Why methods? Because there are two. The first that I'm going to discuss is substitution. And we have the elimination. In Sweden, we call this addition-subtraction method. Not subtraction, subtraction. Method. Okay, we're going to have some example, and then we will solve that by using graphical. We will have easy, y is equal to x minus 1, and then y is equal to 3 minus x. We will graph that. If you don't have any graphing calculator, you need to do this by hand. How to do that? You need to do your table. It's okay to just have 3 points, x and y. And then we will first do the first equation. I will name it this first equation as 1 and the second equation as 2. And we have x and y. It's enough with 3. So when on my first equation now, when x is equal to 0, then y is equal to -1. When x is equal to 1, then y is 0. When x is equal to 2, then we have 1. So if we're going to put that in we'll need new. Okay. Let's see if we can remember. 0, -1, 1, 0, 2, 1. 0, -1. There is the point. 1, 0, and then 2, 1. That's your line. I'll put it. There you go. There is our line. And the next one is when x is 0, then we have 3. When x is 1, we have 2. When x is 2, then we have 1. So 0, 3, 1, 2, 2, 1. 0, 3, 1, 2, and then another 2, 1. If I'm going to connect the dots, then I have the line. As you can see, the point or the dot where the two lines meet or cross each other, then that is my solution. So the solution on this graph or system of equation is, we have solution. I usually write this in this way. My solution is x is equal to 2 and y is equal to is equal to 1, not -1, is equal to 1. That means if I have to look at my solution here, then I will get the same. So when x is 2 in my first equation, I get y1. My second equation, when x is 2, then y is 1. So that's my solution also. This is what we call graphical solution. But graphical solution is very, very, very tedious to do, because if you don't have graphing calculator, then it is very hard to do. It takes a lot of time. But it's easy to see the solution. As I've said in my first plate here, that this is the graphical method, algebraic methods, substitution and elimination. Let's see if we can do some another example using graphical method, but this time a little bit more difficult equation. Let's see. y is equal to x plus 1, and then y is equal to negative 2x plus 1. So this is my first equation, second equation. So we have x and y. It's enough to have 3. For my first equation, then we have 0, 1, 2. I will use those. Those are the easiest. So when x is equal to 0, and then I have 1, 2, and then I have 3. My second, x and y. Then I have 0, 1, 2, the same. When x is 0, then I have 1. And when x is 1, then I have negative 1. When x is 2, then I have negative 3. As you can see now, this is my solution, basing from this. But we're going to do the graph also. We're going to do the graph, new window. Okay, the first one, 0, 1, 1, 2, 2, 3. 0, 1, 1, 2, 2, 3. That is my graph. And for my next equation, 0, 1, 1, negative 1, 2, negative 3. 0, 1, 1, negative 1, 2, negative 3. That's my graph. So if I'm going to connect the plot, the dots, then as you can see, that my solution is 0 and 1, as we have seen here already. Okay, another. We have 3x plus y minus 1 is equal to 0. I'm supposed to put this one, and my answer is x is equal to 0, y is equal to 1. And then we have y minus 2x minus 6 is equal to 0. Now, as you can see here now, it's arranged into this one, y is equal to mx plus b. So in order to graph it, then I suggest that you will rearrange or transform equation 1 and equation 2 into slope intercept form. Okay, then what we can do now is to rearrange like what I've said. So we have just for equation 1, so we have 3x plus y minus 1 is equal to 0. So if I will subtract 3x and add 1 to both sides of the equation, so that this will become 0, this will become 0. So my equation now, or my equation is y is equal to negative 3x plus 1. Now I can make my table. So if x is 0, 1, and 2, as I said, it's enough with 2 actually, but 3 is the third point, will be your control point. So if x is 0, then we have 1. X is 1, then we have negative 2. negative 3 times, and x is 2, negative 6, then negative 5. Okay, and then we will do the second equation. Y minus 2x minus 6 is equal to 0. So if I will add 2x to both sides of the equation and subtract 6 and add 6, sorry, to both sides of the equation, so that this will become 0 and that will become 0, and y is equal to 2x plus 6. And I am ready to do my table also. X and y. So we have 0, 1, 2. Then we have, when x is 0, then we have 6. Then we have 9. This one is not functioning. And then we have 10. No. Now this is 8. And this is 10. It's too big. Then what you can do when it's too big, you have big numbers, then you can do negative 1 instead, negative 2, and negative 3. Let's see. Negative 1, then we have 4. Negative 2, then we have 2. Negative 3, then we have 0. Good. Then it is better to use that. Okay, let's plot. New window. And let's see if we remember. No, I don't remember. Okay, 0, 1, 1, negative 2, 2, negative 5. 0, 1, that's my point. 1, negative 2, 2, negative 5. That's my point. And the next. So we have negative 1, 4, negative 2, 2, negative 3, 0. Negative 1, 4. There you go. Negative 2, 2. And then negative 3, 0. So if I'm going to connect the dots, here also, then as you can see, we have our solution is for negative 1, 4. Let's see if we can find that solution also on the next. Negative 1. So if I have x is negative 1, negative 1 times negative 3 times negative 1 is positive 3 plus 1. That's 4. So my solution, our solution is x is equal to negative 1 and the y is equal to 4. That's the solution. Next time, I will be discussing the algebraic method. Maybe I will concentrate first for the substitution, and then the next will be elimination. See you there.